Welcome to another video of this channel. In this video, we'll explore how a vibration sensor works and how to use it into our projects. We'll learn how to turn an LED on and off with just a flick, and how to detect vibrations to create a simple alarm. So without waiting, let's begin. First of all, let's start by exploring how a vibration sensor works. The SW19020P is a type of vibration sensor, also known as a vibration switch. It is commonly used to detect vibrations or shocks in various applications. The vibration sensor typically consists of a small spring inside a metal tube. When vibrations occur, the spring makes contact with the metal tube, closing the circuit and allowing current to pass through. This change in electrical state is used to detect the presence and intensity of vibrations. Now let's build a simple circuit that shows us the vibrations detected by turning on a LED. All you need is your Arduino, a LED, the sensor, and some jumper wires. Choose a pin from your Arduino and connect it to the long leg of the LED and connect the short leg to the ground as well. Then connect one of the analog pins to one side of the vibration sensor, and the other side must be connected to the ground as well, to be able to detect the vibration pulses. For example, I'm choosing the pin A0 for this project. After you've finished assembling everything, let's jump into the coding part. First, we need to define the variables that we are going to use. I'm going to define an int variable as read to save the values received by the analog read, and another int for the LED pin. Then I'll define a Boolean to check if the LED is on or off. After that, we will initialize the pins that we are going to use. Set the LED pin as output and the analog pin as input. And also, don't forget to start the serial monitor as well, since we are going to print some stuff later. Now in our loop, first we need to get the values received by the analog pin, and we will do so by using the method analog read, and we will store the value in our read variable. Next, you can print and see the variable that you have just received. Our value is something between 0 and 1024. 1024 means no vibration, so no connection, and 0 means vibration with full power and full connection. Next, we will use an if statement to check that if the value of read is 0 or not, and if it is, it means we received a vibration and we will turn on our LED. Also, the LED state must be false, which means it is off already. After writing the statement, we will use the method digital write to send a signal to LED to turn it on. And we will change the state to true as well. In our next step, in order to turn off the LED, we need to detect another vibration, and also the state of the LED must be true, which means on. And if the conclusion of our else if statement is true, we will turn off the LED and also change the state of LED as well. Also, at the end, make a small delay, so our program will have enough time to decide. Now everything is set, let's run and see the result. You can see that we can turn on our LED with a hard flick. And to turn it off, we need to give it another hard flick. You can see it is a little hard to turn it on and off because to change the states, we had to get the value 0, which is the smallest value possible. To raise the sensibility of the circuit, we can do some modifications in our code. You can see that we are receiving the value 600 when there isn't any vibration, but as soon as we give it a flick, we receive less and less values. Now let's change our if statement somehow to detect the values less than 100 and do the operation. Now it's time for uploading the new code to the Arduino and see if we get it any different than before. You can see that here our circuit got much more sensitive to the little vibrations as well. We can even go a step further and add a buzzer to make some kind of alarm when a vibration is detected. All you have to do is to change the place of the LED with a buzzer. Now in our code, we just need to comment out the previous if statement and make a new one. And the condition for it would only be the read values less than 100. And if it is, we will activate the buzzer and wait for 1 second. And also in our else statement, the buzzer is deactivated all time. After uploading our code to the Arduino, we can see that when a vibration is detected, our buzzer activates for 1 second. If you like this video, please like and subscribe for future videos.